Welcome everyone. It's 1 minute past the hour of 1 minute past the 1:30 Eastern time. We can get started. Let me start sharing my screen. All right. Google Chrome, share. So to get us started, I would like to invite you to the Mentimeter pool and go to this Mentimeter pool. You will find the slides that we're going to use throughout the session, and also instructions on how to go into the breakout rooms. And before doing that, I would like to ask help from Jake and Chen to put the code in of the Mentimeter and also the Google Doc for the meeting notes for this session. And in the meeting notes, you'll see a link to the ESIP community participant guidelines, which is the guiding practice for us to create a inclusive and diverse and welcoming environment for all the participants for this session. And welcome to our AI Ready Data session. I am Doug Rao with North Carolina Institute for Climate Studies, also supporting NOAA Center for Artificial Intelligence. I'm located in Asheville and North Carolina. And I'm co-chairing the session with Tyler Christensen, who is with NOAA's National Ocean Services, NOS. I forgot the full name, but it's NOS. If you can go to the Mentimeter pool, I would like to invite you to put your location onto this map. You can hover around your mouse to locate yourself on this map, whether you are right now or whether you were on this map, whether it's for your vacation in the holidays or your most recent field trip before everything got shut down. I really hope we can see some other places outside the US, but it's just my personal bias. I will give it, we have like 18 people in this poll. I hope that we can have a little bit more people. We're 43 people on this call right now, and you can find the code in the chat or on the top of the screen. It's an 8-digit number on the menti.com. And this is just a way for warming us up about, oh, okay. That's the location outside the map, which is kind of like icebreaker maybe. Great. Looks like a lot of people are in the East and Midwest of the US. I should probably have like two maps. One is world map and one is US map. So people can have higher resolution, but we can use it next time. Okay, thanks everyone who put in your location. And since our session is about AI ready data, so next coming up to warm up everything is I want quotes, one quote from Intel about AI ready data. So one quote from them is that you are not AI ready until your data is. And the biggest roadblock to implementing a proof of concept for machine learning or deep learning is sourcing, organizing, and feeding the right kind of data into your model. So that's also a question this data readiness cluster is trying to address, how we can improve the offering and services around the open environmental data to help people adopt and accelerate the AI applications using environmental data. So this is just trying to set the stage about AI ready data. So, and next one will be asking your input as well. So in here, you can put in this Mentimeter, you can try to put in up to 3 phrases. Each phrase should be no more than 25 characters about what does AI ready data mean to you. So let's get a feel of what do we think about AI ready data for everyone who are in this session right now. I see there are 2 people putting parallel-friendly formats, which is really important. Performance, semantics, normalized, and accessible, well-documented, stable. There's a really dynamic word cloud coming up. So feel free to think about what makes the most sense to you. Tools, helper codes, documented. I think documentation come up several times. validated, ethical. I really want to emphasize that one. That is something of my personal interest as well. Quality, high quality, and okay, this like switching back and forth about the directions is making my head turning. But great, thanks. I'm gonna open for like 30 more seconds before we move on to our next slides. So if anyone wants to provide your feedback in this Mentimeter pool, that would be great. And also in the chat, you should also find the documents about the meeting notes, where we invite you to provide your name and affiliation that we can follow up with some additional information about the session.
Hey, Doug, can we share this, or can we save this word cloud in any way? It would be great to,
this will be
share with
exported.
others.
This word cloud will be exported as output from the session as well.
Awesome.
Thanks, Jake. And okay, let's move on. Thanks. We have a lot of conversation about quality, documentation, and access. That will be our discussion for this session today. So I just want to provide a brief background about what the data readiness cluster have been doing in a collaborative way on the AI ready data. So the goal of our cluster is trying to improve the open environmental data to enable and accelerate the AI applications using this environmental data. So in this slide, if you go to follow us on the Mentimeter, you can find a link to our problem statements, description, and on this, how we are approaching this topic. So in the AI ready data, based on the cluster discussion, we identify these 4 sections. One is preparation, quality, documentation, and access, which are basically based on a draft data AI readiness matrix developed by the White House Office of Science and Technology Policy in 2019. And we did some refinement based on that draft and trying to adding additional details in it. So based on this, we drafted a checklist that you can find in the note document later. And we are using this draft checklist that developed community survey on the AI ready data, which this survey is still open. If you can use the bit link bit.ly/AI-ready-data, the data is the survey is still open until the end of this month. We will be deriving the final results from the survey after the closure of this. But with that, I would like to invite Tyler to share preliminary results we got with more than 90 responses on this AI ready data survey. Tyler?
Great, thank you, Douglas. Let me just share my screen here. Just thinking.
Yeah, you're muted. Tyler, you're still muted. We cannot hear you. I see your mouse moving, but there's no sound coming out.
When I share my screen, it mutes me.
Do you want me to share the screen for you? I have your slides.
Yes, please. If you have my slides up, that would be perfect.
Yep, I can do that. Give me 1 second. That's what we're talking about. The first day always have tech issues.
Yes.
Let me share my screen again. Share.
Okay, fantastic.
Right.
Okay, thank you, Douglas. Okay, right. So I'm just going to, on behalf of the AI, the data readiness cluster, I'm going to talk about this survey and the preliminary results that we've seen so far. So just to back up the purpose and target audience for this survey. So the folks that we were aiming the survey at were people who are actually doing AI and machine learning research, and who use open data. And so people who are hands-on data users trying to use open data in AI and machine learning. And so we're gathering info on what specific factors make a data set easier or harder to use. What makes a time-consuming data set, what makes an absolutely easy peasy dream data set. And so we're using this to learn about community requirements to inform a standard, and also to target improvements, because the overall end goal is for AI and machine learning users to spend less time on data work and more time on their science. Next, please. Okay, so what questions were asked? We got some basic demographics and background questions about where they are right now, what kinds of AI and machine learning techniques they use, what data types they use. And then the next sections are about starting to get at detailed requirements. So for data preparation, do they have preferences for gap filling, for whether outliers are handled or not? Do they need labeled data sets if they're using supervised learning? So then for data quality, which of these aspects is the most important? Completeness, bias, provenance, etc. And for documentation, we ask questions about metadata, about parameter definitions, about persistent identifiers. Data access was mostly about delivery method and file formats, and a few questions about how they would like to access restricted data. And then we asked some questions about training data reuse. So have people shared labeled data sets, or have they reused data sets that were labeled by somebody else? Next, please. Okay, so the demographics of our respondents, we've got 93 responses so far. Most are split evenly between government and academia, about 9% from NGOs and about 12% from private industry. So we are hoping to get a more balanced response. So we feel like we've done a great job of the government and academics, but we would like some more input from private industry by the end of the month. So we're doing some targeted outreach there. There's a good mix of research domains, everything from climate to wildlife biology to space weather. So we were aiming at earth sciences, and so we've gotten a really wide variety of research domains. We were a bit surprised to see that we asked, this is the first graph here is about what processing environment do you currently use? And we were surprised to see that 50% of the people who are responding to the survey said that they're doing their work on local machines. The rest of them are split evenly between high performance computing and cloud. So we were a bit surprised to see how many people were still using their local machines to do these advanced techniques. But yes, next please. Okay, so now we're starting to get into the requirements, where we're asking very specific questions about each of those 4 categories. So first we asked about data preparation. And so what we're asking here is, are there data preparation tasks that you would like the data provider to handle so that you don't have to? And so this is asking about whether they want the data gridded or in original observed space and time domains. How do they want outliers dealt with? Do they want gaps filled or not filled? So we're evenly split basically on whether the missing values should be, this is gaps filled and not gap filled. So that's pretty evenly split. There's a pretty strong preference for outliers being included. So you're not excluding any outlying values, but you're tagging them so that people can easily identify outliers and decide whether to use those in their analysis or not. There's a pretty strong preference for gridded in space and time. So not in the original observed space, but regularized in space and time. And then there's a pretty strong community, almost half of our respondents are really looking for tagged data. So they're looking for labeled data sets to use in supervised learning techniques. Next, please. So for data set documentation, so what documentation features are important to make a data set easier to use? Data set metadata, that just means standardized information about the data set. Details about each parameter. This is if you think about a tabular data set, for each column in the data set, you want to know what's being measured, what the units are. Is it floating point versus text? If there are codes in that column, what do the codes mean? So really detail. Oh, if it's nullable, and if there's a null value, so if you're using 999 for null values, that should be carefully documented. So details about each parameter. That's the second most requested. There's a really strong preference for example code and notebooks. So especially if you're working with data sets you're not familiar with, and especially file formats that you might be a little bit less familiar with, having example code or Jupyter notebooks or user guides, or anything we can do to provide an on-ramp to starting to use unfamiliar data is really highly requested. People want to know about the extent as well. So that means the both in space and time, what's the coverage of that data set. So I've included one of the free text answers that we got here, which is lack of proper documentation is one of the most widespread issues that exists currently. So the more you can do to document a data set, the easier it is for folks to start using. Next, please. Okay, data quality. So which data quality factors are the most important in the usability of a data set? Consistency was by far the most common answer. That means from one time step to the next, or from one data file to the next, the data are exactly the same. They're formatted the same, so that once you've written code to deal with one file, you can use that same code seamlessly with no errors to use the entire data set. So consistency is by far the most important. Completeness is also very important. It's a lot of not all, but a lot of AI and machine learning techniques need large data sets, and so putting the whole data set out there for everyone to use, not just individual file downloads, but the whole data set out there to use is really important. And then resolution. This is basically like they need detailed information about the resolution of the data set. And then lack of bias. We can have a whole conversation about what bias means in relation to Earth systems data, but lack of bias was also a very common request. So again, one of the free text answers: complete and consistent data sets are even more important in AI and machine learning projects compared to traditional analysis kinds of techniques. Okay, next, please. So for data access, we asked a couple of things. So the first thing we'll talk about is delivery method. So we just asked how do you want to access the data, and so the options were: do you want to download individual files and store them on in your local system? Do you want to access data directly in the cloud? Would you like to use web services or APIs to access the data, or do you have no strong preference? And actually, a full 17% of our responses said no strong preference. They can deal with whatever kind of delivery method data providers use. But file download is the most commonly requested, and I think some of that is, that's sort of reflecting the processing in your local environment, or in an HPC environment where you basically just have a copy of the data that's available. So this is people's current preferences, but we saw a really smart comment here that they can currently deal with file download and managing big data sets, but shifting to the cloud and cloud access for data sets is a big leap for some, and that they might need funding and assistance. They would like to shift more towards using data in the cloud, but would need funding and assistance and example code and notebooks to be able to sort of ease that transition into getting access to data in the cloud. Next, please.
2 minutes, Tyler.
Yeah. Okay. Yes. Okay. File formats. We asked about a whole bunch of different common data formats. You can see the details in that figure there, but overall, self-describing formats like HDF and NetCDF are good. Text formats, including, that basically means comma-separated values, is preferred by some, but is definitely okay for a lot of people. And there is a sort of a subset of users that prefer some of the cloud optimized formats like ZAR and cloud optimized GeoTIFF. But an important point here is that folks are flexible. So a full 2/3 of the respondents said that they can handle 4 or more formats. So either that 4 or more, they answered either okay or preferred. So there's a lot of flexibility in the kinds of files that people can work with. Next, please. So we asked about training data reuse. And most people have reused either their own training data or data from another research group. And 58% claim that they have either shared or published their training data with other groups. So there is definitely hope on this, this idea of providing training data for others to reuse. Next, please. So I just wanted to highlight a couple of the free text comments that we thought were really interesting. In Douglas's word cloud earlier, we saw this message that AI ready data is parallel ready data. More open documentation with example code was a really common request. I'm just going to read this one. The most common reason I can't use a data set is just that it doesn't have the right content, either in terms of variables, coverage, resolution, purpose. So having all that information readily available speeds up discovery a lot. So part of what we're aiming for here is just carefully documenting the kinds of factors that people might be interested in to locate data that works for their purpose. So this was also a really interesting one that generated a lot of comments for us, is reluctant to use data that I haven't downloaded because there's no guarantees that it won't go away at some point in the future, making it impossible to reproduce my work. So there's a reproducibility issue related to the persistence of open data sets. And then if you get access to a comprehensive data set, so access and comprehensive data set, you can handle all the other difficulties one way or another. Okay, next please. Next is the final slide. No, I've got 2 more slides, sorry. Okay, so overall, except for some specific preferences for data preparation, the requirements are not so different from other large-scale data users. Data quality was the #1 most important factor if you compare data documentation, preparation, access, and quality. Next, please. Okay, so where we're going from here. So I already said we're soliciting a few more responses. It's still open for anyone to respond, but we're specifically looking for a few more private industry folks to respond, just to make sure that we're doing a good job of reaching that audience. We'll close the survey at the end of January, and then we'll do a final analysis, and we will definitely distribute the results and the report openly, so that so this info can be used outside of the cluster. So the next steps that we're talking about is how do we turn this info into a template to score individual data sets, to to assess individual data sets, and then how do we test that scoring and refine our method based on feedback from data users. And then in the end, we're hoping to develop this into a formal standard. So how do we take these sort of community level requirements and turn them into a formal standard? Okay, that's it for me. Thanks, Douglas.
Douglas, I don't think we can hear you right now.
Oh, sorry. I muted myself on my mic. Sorry. Yeah. Thanks, Tyler. And we're going to move on to our use case presentation. But meanwhile, I invite you to provide your comments and questions into note documents that we have posted in the chat, so we can keep track of the questions that have been asked, because the Zoom chat may disappear at some point. So, and the other, I would like to invite the first use case presentation from USGS. Steve and Jess, do you want to go ahead and start sharing your screen?
Yes, I'm going to go first. This is Jess. Let me share. Okay, can you see my slides?
Yes.
Great. All right, so thanks for inviting us to participate. Steve and I are doing a bit of a tag team here. I'm going to launch out, and then Steve's going to join in and talk more about the details of the second part of the presentation. So I'm going to share about LCMAP, land change monitoring, assessment and projection, based on the Landsat analysis ready data. So LCMAP stands for Land Change Monitoring, Assessment and Projection. I think I already said that, but this presentation will focus mainly on the monitoring, continuous tracking of the land surface using the Landsat ARD as the main input. The assessments and projections pieces is more about sort of what happens later and after we monitor, what can we do with that monitoring information. And just by virtue of time, I'm not going to focus on that for a large amount, but really with assessment, we're trying to summarize the landscape change that we've seen and look at causes and consequences. And projection is all about modeling outside of the Landsat record, either to past landscapes or future landscapes. And what we're trying to do is take this Landsat analysis ready data that we've produced at USGS and turn it into more, what we hope is more useful land cover and land change information over larger extents with faster delivery over longer time periods, et cetera, et cetera. So better, stronger, faster, hopefully. And as I said, Steve is going to talk more about our foundational, one of our foundational elements, which is the Landsat archive, which we think is incredibly valuable for this kind of use case. And I'll present a little bit about the products that we're creating in our validation. So this is the, oh shoot, my timer's not going. Anyway, I'll look at the time now. So this is a flow chart of our basic methodology. We're utilizing, to get to this land cover change information, we're using an algorithm called continuous change detection and classification. I've got some papers there that people can consult for more information. And I've got two sort of pieces of this flow. We've tried to simplify it for presentation, where we start with the blue arrow and over here, and we just kind of swirl around the gray bar there, utilizing the Landsat, every pixel in the Landsat archive that's of good quality, going back to Landsat 4 and forward, so sort of early 1980s forward, calculating harmonic time series models on a per pixel basis, utilizing the CCDC approach to determine model segments through time, and then breaks in those models where the land cover or land cover condition change. Producing products, the products are sort of shown in these green boxes. And then further on down towards the bottom, after we run the change detection part of this, we actually take the harmonic model coefficients from that change detection and then classify, utilizing machine learning, a machine learning approach, boosted decision tree, classify into annual land cover. And again, some more products are created down here. And what we think is unique about this is that we're calculating the change first and not the cover first, and doing what is changing from the cover. So it's kind of a change in order of our analysis. And then all of the products are integrated with each other. Yeah. Okay, so this is just a really quick per pixel look at Landsat ARD on the upper left, changing through time. You can kind of see towards the end of the record where the SCR problems with Landsat 7 come in. And on the upper right is a product that we're creating, the time since last change. The plot shows that pixel behavior through time, and the Landsat observations are shown in the dots. Moving on, this is the product suite that we're creating and putting out there right now. We have a collections approach. We started with conterminous US, and we're now expanding into other areas, but We're up to what we're calling collection 1.2. So this is based on collection 1 Landsat. And through 2020, over the conterminous US at the Landsat resolution, basically 30 meter spatial resolution. And actually tomorrow is our planned release for Hawaii, which is a shorter time period, but 2000 through 2020 over the 8 ARD tiles of Hawaii. Steve will talk a little bit more about ARD tiles in his section. We produce these 10 products. They're integrated, as I said before, and on the bottom row come directly out of the CCD part, the change detection, and the top row of products come out after we do the machine learning approach. We have 8 land cover categories. So it's based on the Anderson level 1 classification scheme. And we also do produce and release reference data and validation for our products. We've collected 25,000 independent reference data plots across CONUS. Right now, our reference data is up to date through 2019, and we're just getting ready to extend that through 2021 using photo interpretation and a bunch of ancillary layers that help us identify cover and change for these reference data points. They are also available in the locations shown, and they're used to validate our annual land cover maps through time. And I also have listed a reference here of that paper that was just released in 2021, showing our validation. So our primary land cover accuracy is hovering around the low 80s. 82.5 was for collection 1.1, I believe. Stable accuracy across the record, but we're seeking to improve our land cover accuracy going into the future. And with that, I turn it over to Steve.
Okay, thanks, Jess. Can you hear me okay?
Yes, great.
Yes.
Yeah. All right, terrific. Okay. Oh, Jess, you came out of full screen. Okay, well, I'll just try to keep talking here. Well, now I can't. Lost your screen. Maybe it's just on my end. Does anybody else see it?
I saw Jess start sharing the screen, but it's not showing up yet. While we're troubleshooting, I just want to lay a background. So these 3 use cases we choose are trying to lead our breakout discussions later on. I know everyone will feel like breakout sessions can be, you feel like you don't have anything to contribute, but even just you want to like join the session to listen in, that'll be totally fine. And
I'm hoping
so
it's showing now. Sorry. It
don't-
says I'm sharing my screen.
I don't see it yet because it's
Still a
still
black screen.
Yeah, it's still black here.
It's
Maybe
weird
I
because
can-
on the Zoom it says I'm sharing, but maybe somebody else. I'll try it one more time.
Can I take it, Jess? Maybe I can try it.
Yeah, if that didn't work, go ahead, because it says I'm sharing my screen.
Still not showing on my end yet.
Okay, I'll stop. Go ahead, Steve. Apologies.
Can you see my screen?
Yes, we can.
Okay, so let me pick up here where Jess left off.
Maybe like 5 minutes if that's okay.
Yeah, I'll go really quickly.
Yep.
Okay, so everybody's heard about analysis ready data, and we're here to talk about AI ready data, but I just want to kind of set the stage of what the input is to this LC map capability that Jess just described. So this is a data set over the US. It's got the highest possible radiometric and geometric quality that the Landsat record has. We have per pixel data quality flags, so we can do filtering on that. We've got per pixel metadata, and then we've tried to process this to the highest levels so it's ready to use by the LC map system. And really what we're trying to achieve is to make sure that every observation, every pixel is available for time series modeling. So the US analysis rate data for Landsat Archive is a subset of the entire USGS Landsat collection product, which you might be aware of already. LCMAP is still utilizing collection 1. However, we are working towards a collection 2 implementation in the cloud. So we only use the best data. So this is what we call tier 1 data out of that collection. It's got a less than or equal to 12 meter RMSE. It's TM and OLE data, so which really means it's from 1982 forward, and it's over CONUS, Alaska, and Hawaii. We've got measurements for top of atmosphere, surface reflectance, and brightness temperature. And we make use of, for LCMAP, 5 per pixel quality assessment bands. And this is placed into an Albers map projection over the US. And we're using what we call weld grid system. So you can find out more information there at that link. So what does this kind of look like in pictures? So here's the grid. We've got both a horizontal and vertical indexing system. The output products that Jess described are also provided in the same reference system. There is some overlap in the scene data. So we do a compositing to pick out the right pixels. And so multiple images do get merged and we fill the remaining area. The per pixel quality assurance bands, as well as the metadata, are also composited in the same manner. And so this kind of basically gives you a predictability through time. So we go all the way back to 1982 from Landsat 4 all the way forward to Landsat 8 today. Of course, that archive will grow. We're about ready to announce Landsat 9 becoming operational and those images becoming available too. One of the things that that we've noticed and others will notice of this archive, though, is there are some variations, and there's some seasonal variations which are kind of outlined in the gray bars, but we also have variation in the clear or water pixels. So we subset out the pixels we want to use. We exclude clouds, for instance, and we pick out the clear water pixels only for the LCMAP system. Okay, so of course there can be some challenges with this. Our ability to detect land surface disturbance really depends on how long the disturbance is, that duration, as well as how frequent we have for observation. So the record isn't entirely complete. Perhaps incorporating additional data sets may help with this. And we also are looking forward to, and I mentioned earlier, the collection 2 data set. We're hoping that there's maybe some improvements in data quality. We know there's improvements in geolocation, in the measurement consistency, and we know that more observations make it into what we call tier 1 data. So we're hopeful that we'll increase the observational frequency too to overcome some of those challenges. And then I'll just probably conclude here. This is a little diagram showing our notional architecture going into the cloud, providing hopefully great access for both LCMAP's current users internally as well as public users to the outside. And I've got a few links there for LCMAP data access. There's a data viewer we have. We have CONUS mosaics, and also just for the underlying Landsat data archive, there's a link to the Landsat data access page as well. And I think everything else is in backup. We can provide those later, but I think that's all I have.
Thanks, Steve. Thanks, Jess. And if you have any questions, please feel free to put in the notes. And Steve and Jess, if you see any comments about your presentation, that you can go there, answer as well. Thanks, Steve. And
absolutely.
So, yeah. We just heard a use case using satellite data and it's analysis-ready Landsat data. So we can have more discussion in the breakout about what's the difference between analysis-ready and AI-ready. That's a whole discussion that we invited Steve to our cluster meeting 2 months ago, I think, talk about that. And next use case, I would like to invite Seth from NCAR to present his work with the model simulation downscaling. Seth, please.
All right. Can you see my slides?
Yes.
Okay. So our use case for AI data readiness is downscaling climate model outputs using a convolutional neural network. And so what our goal here scientifically is that we want to develop a CNN, a machine learning approach, to do regional climate model style downscaling, by which we mean taking upper atmosphere variables that are coarse resolution as inputs and producing much finer resolution surface variables as outputs, the same way that a climate model does using physics. And we thought, well, let's try this, because this is pretty similar to super resolution downscaling, which is or image processing, which is a well-established method in machine learning-based image processing. And the scientific question we want to ask is, are these results at all credible if we use a machine learning process instead of a deterministic physical model? Like, is it possible for a machine learning method to get the right answers for the right reasons, or is it just going to produce pretty looking nonsense? And so that's what we're trying to do with this, and that informs some of the ways that we approach our architecture and things like that. I won't go into any detail on this. This is just a real quick view of what we're doing. We're using a UNet architecture, but one leg is longer than the other. And we're taking 8 different upper atmosphere variables at 2-degree resolution over a big chunk of the central US as our inputs. And we're trying to produce as outputs 1/4-degree resolution surface variables like precipitation and surface humidity and daily minimum and maximum temperature and surface winds and things like that. So this is what we're trying to do. And there are a lot of architectures that might give you much better results, like if you're using a GAN or something like that. But we were not trying to get the best possible result. We're trying to get something where we can understand what it's doing and judge whether what it's doing makes sense. So we intentionally picked a very simple architecture. And our initial results are pretty promising. So here we're showing in the top row 1 day from our validation data set, which the model has never seen as input. The top row is daily maximum temperature for a single time step. The bottom row is precipitation on that same day. We've got our gridded observational data set on the left, a regional climate model on the right, and the output from the CNN in the middle. And that looks like weather, so that's pretty good. It produced something that looked reasonable. And now we're trying to understand, okay, the results look reasonable, but are they actually? So that's the science we're trying to do with this. In terms of the requirements for AI readiness, data discovery, in our case, it's pretty simple. We're using well-known climate modeling data sets, CMIP5, gridded observational data sets, ERA reanalysis. So, we kind of don't really need to do much other than have some prior domain knowledge and do some Google searches. For documentation, we do need to know space-time coverage and resolution and what the variables are that are in a particular data set. What does this have in it? And it's also to have information about how was this data generated? What went into it? What were the original sources of data going into, like the gridded observational products? And what algorithms did they use and stuff like that? Because that has implications for how meaningful various parts of the results of our machine learning are. And I will also add that sample visualizations of a data set can be really helpful, because if you just got a map of like, here's an example of some of the data from this data set, that can communicate in a single picture something that would take a long time to figure out what it means in words. You just look at it and say, oh, okay, that's not at all what I wanted, or, oh, okay, I understand the spatial domains of this. Yeah, I think that'll work. For data access, we are doing download, as are many people. So, it's helpful to have a bulk download interface and for things to be systematically named, and all the files to be named in a descriptive way that's consistent, and to be, organized and things like that. And especially if things have community standard names, that can help a lot, because then you don't have to spend lots of time renaming everything to all be exactly the same. In theory, having everything in the cloud should make it easier. But one of the big barriers we've found is that that's only true if all of the data sets you want to use are already in the same cloud. Because if not, then you have to say, oh, well, 3/4 of the data sets I want are here, but one is not. Where is it? How do I get it here? Oh, it's in the Google cloud and I'm working on the Amazon cloud. What do I do? I'll just download it. And the other concern with API-based access is the question of reliability and stability. So if I'm using an API to get the data, can I get exactly the same data using exactly the same query later on, like even 5 or 10 years down the road? Because, you know, that comes up in scientific research sometimes, as you say, oh, I want to go back to this old project and extend what I was doing. And if you can't get the same data that you used the first time, that's a real barrier. That was one of the points that was made earlier. In terms of data quality, holes and gaps in the data can be troublesome. Missing values, as long as, you know, they've been properly encoded, are sort of much easier to deal with. So for this kind of application, you really want a consistent, you know, block of data that's always the same size and always the same shape. And if there's data missing from it, it's been, you know, encoded into some kind of, in some way that makes it easy for you to indicate where the data is missing. But for this application, most of the other data quality issues just kind of don't really apply, because either we're working with simulation outputs or really heavily processed observational data sets. And that means that either it doesn't happen or the issues have just sort of already been dealt with. You know, GCMs don't really produce outliers. If they produce weird values, well, the model data is what the model data is. So I'm lucky in this application that there's a lot of this stuff we don't have to worry about. Data preparation is mostly about taking data from multiple input data sets and getting it to all line up. So we have to do, you know, so we have to get everything onto exactly the same domain and exactly the same grid. So we need to do spatial subsetting. And if it's high resolution, we need to coarsen it. If it's medium resolution, we probably need to regrid it onto the same grid. If it's low resolution, we probably need to do some interpolation. So those are often things that get done on the user end, but, you know, if a data provider can provide something that either something that's sort of in a very standard format, or, you know, that's already been processed, or provide on the fly processing capabilities to do that, that's a big savings. And then we also have to have like the same variables from every data set. So there's a, you know, we have it, often I spend a lot of time like renaming things from this data. You know, people use slightly different names between this data set and that data set, and, you know, putting things in the same units, because this one is in Kelvin and that one is in Celsius, and this one is in millimeters per day and that one is in kilograms per square meter per second for precipitation and things like that. Sometimes you have to calculate derived variables like, oh, I want relative humidity, but I only have specific humidity. But if I've got specific humidity and temperature, I can calculate it. You know, I can calculate relative humidity and things like that. And then normalization is a concern, but we do that inside the CNN. So that's not something that data providers particularly have to do, but it is useful to have information about what the range and distribution of the variables are, because that is really useful information for when you're doing a normalization on the fly. So those are what the requirements look like for this kind of application.
Right. Thanks, Seth. That's a lot of information that we need to take in, but thanks
I apologize for spewing so many words at you, but I'm happy to share slides if people do.
I think it's really exactly the information we want to like see at this session. And so with that, I would like, again, direct any questions or comments you have into the documents. And with that, I would like to invite Stephen, who will share about his use case. Stephen, you can start sharing your screen while I'm talking, and about his use case about combining the model and the observation for the post-processing. If you can do it in about 7 to 8 minutes, that'd be great.
Let's hope so. Should I start?
Yes, please.
Yes. Hello, my name's Stephen Heller, and I'm a scientific software engineer at the Met Office in a group called the Informatics Lab. And I'm presenting today on behalf of some of my colleagues who've worked on the Improver post-processing system at the Met Office and a pilot project to use machine learning to improve site-specific temperature forecasts. That's the use case we're thinking about today. So the overview of the application is Improver, which is the next generation post-processing system being developed by the Met Office, which is aiming to better exploit our ensembles that we produce, both globally and over the UK. And also create better consistency between the various outputs we have, which have kind of different processing streams at the moment. So sometimes to kind of tell a different story, so be more consistent in our outputs, and also have a more probabilistic treatment of most of our outputs as one of the ways of making it consistent. So this particular project within that was to use machine learning to improve sort of skill scores on our site-specific screen temperature forecasts. That was the initial goal, but also to explore kind of doing post-processing on various variables in a gridded way, so to improve that kind of consistency between outputs. So our use case summary is that the Met Office wanted to train a machine learning algorithm to produce a better forecast of temperature at a site-specific temperatures based on forecast model output and verified against observations. So I'll just take a quick look at each of the 4 key questions around this: data discovery, access, quality, and preparation, and see how it applied to our particular project. So firstly, data discovery. So this is all kind of Met Office produced data and mostly internal data. It's not easily accessible externally. So, and to a certain extent, data discovery was not so much of an issue for the team working on this project, because this is data that they're familiar with working with all the time in terms of creating the post-processing system. It's all about using it in a different way with machine learning. So for them, it was very easy to discover the data, but it does bring up the question, if somebody else wanted to now reuse this data set to further explore ways of using machine learning with model data, could they find the data as easily? And I think the answer is probably no, because conceptually we know it exists somewhere in our archive, and we know conceptually what data is there, but actually finding the particular files that you need can be difficult. Similarly with the observations, we know it's there in our observations database, but actually finding where it is as somebody who's not working in post-processing day in, day out can be a challenge. So even within the Met Office, making that data more visible is still quite a challenge. What about data access? Well, this was the key challenge for this project, because we were dealing with huge numbers of files and very large data volumes. So the data set that we're working with is an order of 100 terabytes, which was initially stored primarily in a slow access archive and needed to be extracted then and brought together into a way that could be more easily accessed by the machine learning pipeline. And even just the sheer number of netcdf files which are stored in proved to be challenging for the software that would then load and process the data. So one of the solutions I've been working on in the Informatics Lab is the concept of we call a ZAR hyperthetic cube, which is the idea is a ZAR wrapper around all these netcdf files to make it easy to access the data in a sort of consistent memory object without actually having to load it all. So without having to go through a massive conversion process of all the data. And so this is continue being developed to be used in future to make the data more easily accessible, potentially interacting with our data archives to make that part of the process easier. So data access has been some progress in making it more easy for future work to make use of this data set, but that work is ongoing. So that's data access. What about data quality? Well, from a data quality point of view, this is something that we're pretty confident about. This is our sort of gold standard operational forecast outputs. We have whole teams of people analyzing it and verifying it and checking that it's good quality from a weather forecast point of view, and it's complete and consistent as a general weather forecast data set, and similarly for our observations. An interesting question, though, is does that make it inherently good quality for use in a machine learning application? Is data quality the same for the general uses we have for that data as for machine learning? I think it's largely the same, but I think there could be more exploration around what additional things we need. Certainly, at least in this case, as with Seth's case, in general, models don't produce kind of gaps in the data, so that makes that process easier. In terms of quality, though, kind of metadata and documentation, that's perhaps a little bit less good. There is a lot of metadata associated primarily with the model and describing the outputs, but it's not always kind of co-located with the data or easy to connect where you find the data itself with the metadata that explains it. So again, coming for the post-processing team who works with it all the time, that's fairly easy, but for someone coming new to the problem, fully understanding this data set based on the metadata and finding the relevant documentation can be tricky. So kind of bringing together all the sources of information is one way this can be improved to enable future machine learning projects to make better use of this data. And then finally, data preparation. So this was conceptually kind of simple, but very time consuming and slow due to just the sheer data volume and number of files. So the process was extracting from the tape archive to a local storage area. The processing was all going to be done on the cloud as part of the kind of exploration of how we can make better use of the cloud for our post-processing. So then moving huge volumes of data up to the cloud was a big problem. And then figuring out what is the best cloud optimized structure that would fit in with the machine learning pipeline. And that was the ZAR hypothetic cube I described earlier. So creating all the relevant metadata so that the files could be, the sort of workflow could be loaded without loading all the data. So a lazy data kind of paradigm. And then extracting the relevant features and transforming them for machine learning. So having some of the data perhaps in already transformed and extracted for machine learning would be useful, having perhaps an API, because lots of people are going to be doing the same process if we're going to be using this model output for future machine learning projects. So rather than rerunning it, so something we can invest in further based on the experience with this initial post-processing project is things we can do once and then other people reuse in future. So ultimately, the goal was to produce an object in memory like this. So this is an X-array, and it's an interface to a huge data set with a kind of lazy loading. So I'll skip over that, but just move straight on to the conclusions from this project that we're going to hopefully make use in a follow-on project, which actually I'm involved in, for post-processing of precipitation fields. One is that knowing what data is available sort of conceptually and where it is, in theory, is still a long way from being able to actually find and access the data, even when you're within the same organization. That can be challenging. So further work required there. We found that in general, the access patterns, though, for machine learning pipeline were much the same as other kind of uses of this data would require. But in general, that consistency and completeness that is required for machine learning, other applications can kind of work around some issues with data more easily, perhaps, than machine learning applications. An important thing I found, both in this and in fact some of the other pilot projects you're working on, is the importance of having the domain knowledge associated with the data set to understand what is an appropriate use for different sorts of data. And ideally having that in kind of metadata and documentation with the data itself. I guess the sort of traditional way of doing this is you've got to somehow know the right person to talk to and extract the metadata from their head. We should in future aim to kind of have that more easily available so it can scale up to lots of people using this data set without having to find the right person to talk to so that there's not a blocker for their machine learning project. So those are our lessons learned so far from our initial post-processing machine learning project and data engineering. Thank you.
Thanks, Stephen. And that's also a really interesting use case. And I'm about to say the magic words. So please don't leave just yet. Oh, I see 2 more people join, which is great. And so even if you think you don't have anything you want to offer during the breakout rooms, please don't leave. You can always be the fly on the wall to listen in to what people have to say. So I'm gonna just briefly share my screen for navigation purpose. So we're gonna have 4 breakout rooms. The first one, data preparation, will be in this main room. So if you don't choose any breakout rooms, you'll be staying in this data preparation main room. And for the second is the data quality. And third is data documentation. And the fourth is the data access. And that's the breakout rooms, which Megan is helping us to open the room right now. And with that, I want to point your attention to our meeting note document. So if you follow my screen, going to the page on the agenda about the notes for the documents. So we have a link for data ready, AI ready data checklist. So if you open it, for each breakout rooms, we are focused on one specific section. So if you are in the data preparation, you'll be focusing on discussion on this section. And if you are in the data quality section room, you'll be focusing on discussion about the items on this data quality, etc. So the same for data documentation as well as access. The goal of this breakout room session is to identify what improvements should be made to the checklist, and that we can use the checklist as a way to build a community guideline. So again, if you don't want to go to any other rooms, stay in the main room for the data preparation, but if you are interested in the data quality, go to the room on quality, documentation, or access. And you can always move around between each rooms. Megan, is the breakout rooms ready?
Yes, how long? What time would you like them to return?
We'll return 5 before the end of the session. So 5 minutes before the end of the session. So we'll have like 20 minutes.
On it.
Yeah, thanks.
Mm-hmm.
And you have any issues going to this room, let us know. And each room will have a moderator. For the preparation is Jordan Watson, and for the data quality is Rob Redman, and data documentation would be Tyler Christensen, and data access would be Eric King, and they'll help navigate discussion and also capture the notes.
And the breakout rooms are now open.
Thanks. And if you have issues going into any room, let me or Megan know so we can put you into different rooms.
And so data preparation will stay in this main room, correct?
Yes, correct.
And we'll just give the numbers here a minute. I'm watching the number of participants dwindle.
I'm sorry, how do I join different rooms?
So if you move to the bottom, or there will show up a breakout rooms if you are using the most recent version of the Zoom. Or you can just let me know. Are you going to the quality one?
Yeah, this is Pena. I like to go to room 2, data quality.
Thanks. I'm gonna assign you there.
Okay, thank you.
Yeah. Anyone have issues moving between rooms? Let me know. I can assign it. Or Jordan,
Hi, Doug.
Yep.
This is Jess. Could you put me in room 4, I think?
That's for the
data access.
Okay, yep. I'm on it.
Thank you.
Access. Jordan, you seems to have a big crowd here.
Yeah, the numbers are still dropping a little bit, so I thought I'd wait and see, but I think no, still dropping. We'll give it one more minute and just let folks settle out, I think.
Put me the serial improvement doc says for some reason doesn't work for me.
Let's start share my screen. And so are everyone here trying to stay at this data preparation room, or if any of you want to go to different rooms?
I would like to go to the serial improvement to access room.
Okay, I can do that.
I can do that if it's helpful, Douglas, so you can focus.
Okay, yeah. Any other people want to move around? The quality room seems a little bit thin.
I guess people aren't interested in data quality.
That's not true. Last session, well, Jordan, you can go ahead, I think.
Yeah, okay, so I'll go ahead and just introduce myself real briefly while folks are here. So my name is Jordan Watson. I'm currently doing a 6-month rotation with the NOAA Center for AI. In my normal day job, I am a statistician at the Alaska Fisheries Science Center in Juneau, Alaska. So right now, kind of wearing 2 hats. One is from the AI ready data and trying to get the data ready, facilitating the survey information. And on the other side is as an analyst interested in using data and making them more accessible. So I think we'll start off. So we have a couple of prompt questions, and so if you all, I'm assuming you all have that notes document open. If not, let me know. We're at the top of that document under data preparation. I see a lot of anonymous Google animals. I see an anonymous llama and an anonymous dragon. So it looks like there's a bunch of folks in the document here. So those are a couple of the bullet points you see under data preparation. Fields like, have null values or gaps been filled? Have outliers been identified? Is the data source or data single source or aggregated? Have the data been gridded? Have targets been identified and labeled? And so one of the questions that the first prompt question around these data preparation steps or attributes we have is based on these preliminary survey or use cases, is there anything we're missing, anything that needs to be changed or removed when you think about data preparation? And I'm going to go ahead and mute in between so I can type some notes. And if somebody wants to go ahead, and if there's anybody that has a thought on that. And I'll actually post in the chat the prompt question we're looking at here. So it's based on the preliminary community survey and use cases. Is there anything that needs to be changed, added, or removed regarding data preparation steps?
Hey, Jordan, Hassan here. Hassan Mustafi from USIS.
Hi, Hassan.
Yeah, I think the second point, much more relevant to the data quality, I think. I mean, have outliers been on, well, yeah, yes and no. You know, that should be, when you are doing data quality, that's something you can flag. And then, well, yeah, it is also relevant to data preparation, I think. I don't know, I just see the second point is more data quality relevant than data preparation.
Yeah, I think that's a great point, and I'm looking down at data quality right now to see if it also appears there. And maybe what I'll note is that perhaps the outliers should appear in both sections, so that one, of course, the quality aspect of the outliers, but if folks have done something to the data set regarding outliers, we need to know what that is in the preparation step, right? Would that be a valuable response?
So let's think about it in practical way. I mean, so in data quality, you are going now to find those outliers and you're going to address them in the data quality, my understanding. That's what you do, right? I mean, you have a data, you look at the quality of the data, and then you start, working on if there is outliers, stuff like that. Then in data preparation, what that action will be in data preparation. Basically, I don't know. I feel like, is there still, you have to address the outliers in there? You have to identify them. Maybe it's not identification of outliers there, is more of, yeah, I'm just thinking here. I'm just thinking what is that action will be in data preparation when you receive the data and it passed already data, or are we talking about data preparation? It happened before even to look at data quality. So there is something here that we have to think about, the way that we do a data, preparing your data set.
Yeah, I think your framing there in that last sentence is the key. In order to, what steps were necessary to prepare the quality data set? And so having an idea of what was done to identify and label or process something, the outliers, then it's a matter of preparing the high quality data set, right?
Right. So the action is not identifying, but it's rather is how the process to identify those outliers. That's what you're talking about, Jordan?
Yeah, so what needs to be done with the outliers in order to make that, in order to, let's say, to deal with the outlier before you can then, to make it AI ready, right? So you'll have to do something with them, or maybe you do nothing with them. And that's the question is, do you need to do something with them in order to make the data set AI ready?
Yes, you are going to deal with them. But the question is that, is it during the data preparation? I think maybe folks in the call maybe have more ideas. But I think,
yeah,
yeah, go ahead, Jordan. Sorry. Go ahead.
Yeah, I was gonna say just to make sure, see if someone else has a different framing or comment on this. Does anybody else see a problem with having outliers in the preparation step, or is there a way that we should be rephrasing the question to more appropriately capture how outliers should be considered within the process of preparing data for AI?
Do we use the raise hand thing, or do we just bring in the question?
Go for it.
All right.
We'll see. If people start stepping on each other, we can use the raise hand, but let's see how it goes. Thanks.
Okay. Anyway, I'm with Hassan there. Is that when you talk about data preparation and data quality, to me, they are one and the same thing. But that is not actually my question. I wanted to ask you, you made mention earlier about the steps in data preparation. Can you just remind me where are these steps right now? Or can you share the URL for this?
Yep, stand by 1 second here.
And then perhaps I can,
Yep,
I can be clear about what is data preparation and how it separates from data quality.
Yeah, I just posted the link in the chat.
Okay, thanks a lot.
And is it Armin?
Yeah. So I have a question. Talking about outliers. So for tasks like anomaly detection, I guess we don't want to. We don't know exactly how to frame it as an outlier or any other types of anomalies. So I mean, my initial thought is that we don't want to get rid of them definitely, because they're getting rid of our anomalies, potentially in some of those tasks. And the question that I have, are the null values the same as masked values? For example, if you have a cloud or some sort of data point in some of our scenes that we want to mask it, but underlying that mask, there's a potential value that is not necessarily null. Maybe we want to, at some point use that value under the mask. So I don't know if they're exactly the same or not. Any comments on that?
Thanks. Yeah. So to turn your question into maybe an edit, would we want to change that where the bullet point that says have null values or gaps been filled? Is there a would I edit that? Would we edit that to say, is there additional information about how nulls might be masked?
Yes, because I guess, you know, the null kind of implies that the value underneath is not valid, but mask has a slightly different, you know, connotation. I guess, you know, it means that there's some value underneath that may be valid, but maybe for the sake of, you know, this analysis, we don't want to use it, for example. So there's an uncertainty, you know, in mask values. Null is very, you know, strong word, I guess. And I worked with some, you know, a lot of some, you know, Landsat dataset and Sentinel. For example, mask values underneath that sometimes you want to use those mask values. But yeah, that's my 2 cents.
Yeah, I think I'm following you. And so trying to clarify, basically add a little bit more detail under null and not simply say null, but is there underlying information associated with that has been masked, and can we get to the original or raw value that
yes, exactly
lived there for lack of a better term?
Yep, exactly.
Okay. Yep. Yeah, I'll add that on here. And is it Chung Lin?
Yes, that's correct. Thank you, Jordan. I have one input here. When you also earlier mentioned about the quality, but to me, I think the quality is the next level. So in terms of preparation, I always believe when we prepare for doing AI, the expertise knowledge should be very important. So what I mean, try to say the data relevancy or data adequacy, for the AI machine learning, that would be the top. For instance, if you want to study a hurricane, to simulate hurricane, right? Not only the wind speed, also for instance, like the pressure, sea level pressure, should be considered as well. So then when you get all the data needed, can be better to do the AI job on this particular subject. Then you go to look at for the data quality, how good this data are accessible to you. And so that's I think the data relevancy, depending on the domain knowledge. So usually I would consider, when engineer or the AI data scientist try to work, then probably to connect with the research scientists or domain expertise to get the right data set, inputting the model. Then I think the effect will be much better. Yeah, that's my point. Yeah, that's probably data relevancy. Should be very important. Of course, data quality. That's very important as well. But that will consider we get all the data needed first. Then we're looking for the data. Without data in good quality or not. Yeah, that's my point. Thank you.
Yeah, that's a great point. Thank you, and I've jotted some of that down. I see next hand up. Is it Gay Ping?
Hi, this is Ping. I have a question about data preparation, and looking at the checklist. Consider some the presentation mentioned that they want the names to be consistent, the file shapes to be consistent, and there are some discussions in the community about the patch size. You want to be large enough. I think the number, the 512 by 512 has been mentioned. I'm just wondering whether it would be useful to have some indication here, some kind of consistency And do we need to include that for data preparation?
Yeah, thanks. And so just to clarify, so do you see the consistency as a component of the preparing of the data, or as the documentation so that the end user understands how to compare the data sets?
That's a good question. That could also be addressed in data quality, right? Consistency is part of that. Let's see, the automated to monitor consistency, data quality, measure, reduce bias, but it doesn't really talk about the naming conventions and consistency, because I think it's probably in the data preparation. That's where you have to deal with it, right?
Yeah, and I'm trying to think to a couple of Stephen Haddad's last points. I think it was his, or maybe it was Seth's. Oh, it was Seth's actually, where Seth was talking about having the same grid and domain, having variables with similar units, and
right. And I think those seems to be good factor to consider when prepare data, right?
Yeah, that's great point. Thank you. Yep. Yeah, we have another hand. Is it Philemon?
Yeah, Philemon. Yes, me again. Now that I've read all the bullet points, seems to me that there is a little bit of confusion here. So I'm trying to get my brain wrap around what data preparation is. Because when you talk about data preparation, the first thing that comes into my mind would be the metadata. Are the metadata complete? Is the metadata, can we go back to the metadata to be able to identify probably data quality and things associated to it? And it was never mentioned here. Probably it did. The another thing that came into my mind are if you're using images, are they really properly annotated? So those are the things that came into my mind when you talk about data preparation. So those that I have on the checklist as like, have null values gaps been filled? I think that's data quality, or probably it is part of the data preparation. So there's really a gray line, a very thin gray line between those two. Yeah, I would like to see more of the metadata and annotation in this checklist for data preparation.
Thanks. Yeah, that's a great point. I think certainly when you look at if we looked at a Venn diagram of the data preparation, quality, documentation, you're going to see, I think, a lot of overlap, especially, do we say that the metadata is part of the preparation, or is the metadata part of the documentation? And that's probably, it might be a perspective standpoint of how you're going to use the data and how familiar you are with the data, perhaps. But I've written this down in terms of thinking about metadata and thinking about the nulls as a step, a little bit more fluid component of this process. And so I see folks are starting to filter back in. So I think since one of the other session leaders has shown up, I think that means our time is up for now. But feel free to put, if you have additional comments and you want to put them in the notes document from the overall session, I'll go ahead.
Jordan, sorry, I just want to say a couple things before we close here. I 100% agree with Philemon what he said. It doesn't seem what we have in this list right now anything to, well, it's deep into the details and nitty-gritty of things like values, gridded. I mean, there's some data that doesn't need to be gridded. But anyway, I think we're back to, I don't know, I get kicked off or whatever. Well, anyway, it seems like not what is right now. It's something else. It doesn't represent the preparation. Metadata is one of them. Notation
Yeah, so
is
I think one of the clarifications here is it's describing how these data have been prepared. But we can, I just posted the link to the broader notes document. So if you have other comments, please feel free to put some of those other comments into the chat message here. Looks like we've got Douglas is back and sharing a screen. So I'm going to go ahead and end our data preparation chat here so that others we can return to the rest of the presentation. Thank you all for the contributions or input, and feel free if you have additional comments to post them into that document. Thank you.
Yeah, thanks, Jordan. Like Jordan said, if you have any additional comments, please leave it in the notes so we can keep all of them and then follow up with you and invite you to our a monthly meeting as well. So right now, I would invite everyone go back to Mentimeter. So right now, assuming that you have the ability to invest in the improvement for specific sections of this data to improve its AI readiness based on what you've heard today and what's in your mind is AI readiness means. So the effort is on the x-axis and y-axis is on the impact of the improvements. So what do you think, based on your perspective, what's the improvement and what's the effort for improvement, what's the impact? So it's kind of like cost benefits analysis, and that can help identify the priority, what should be the high priority for the improvements. And while doing that, I'm gonna waiting for more people to chime in because we only have 4 people in here. So again, the same code for the Mentimeter, 3264F4587. Anyone can contribute here. And I want to invite everyone to join our monthly telecon. It's every second Wednesday of the month. That's for February will be February 9th, I think, 1 to 2 p.m. Eastern time. And on the note documents that you will see a link to join the cluster newsletter email list, and somewhere, if I can find it. Oh yes, there is a list to join the email list, and we welcome everyone to join the email list. And also please spread the word about our AI Ready Data Survey, which will close January 31st this month. And also thank you to all the session supporters, Megan, Chen, Jake for this, and all the moderators of each room. But we're not done yet. So here, looking at the input from everyone, seems like we have a cluster here that think everything should be improved, and there's a big impact. But there are certain like have higher priority. And so, for example, data access seems to have a less requirement for the efforts, but like higher impact for the improvements. And please, if you are not on the Mentimeter, you can still join here. And while we are waiting people to respond, anyone can also leave a comment here or like provide any additional suggestions if you have any you want to speak out right now. And while we waiting other people to fill in these results. Pen, I saw your hand raised. Do you have any other comments you want to make in the earlier discussion? Is Pen still here?
Yeah, well, that was from early discussion. I was wondering whether it's feasible to have a generic workflow for data preparation. That might be helpful, but I'm not sure that's a part of what you are getting at.
Yeah, I think that's a good comment. Maybe it can be combined with some data documentation like the notebook. So providing some notebooks how to prepare the data in for different type of applications, because not all the, like Hassan mentioned, not all the data need to be graded. So for some applications, some of them they want the raw data because they want to use the raw data to develop some specific algorithms or applications. So maybe some type of a notebook documentation would be helpful.
Yeah, I think that would be good for the reproducibility and traceability part, but for new people coming the field, it's just more of a diagram type, scope out the steps, different phases for what needs to be done. And that it's more of a guidance might be useful.
Yep. Yeah. Thanks, Ben. And since we are 1 minute past hour, I would like to thank everyone who joined our session today. And this poll is still open. So if you haven't got a chance to provide your comments or feedback about this, and we also have 1 slide for additional questions. So if you have anything, please leave them in the document so we can follow up as well. Thank you, everyone. And thanks, Megan, Jake, and Chen for supporting this session again.